Hello everyone. Today we'll be solving AQA question paper for GCSE chemistry. Today we are solving the higher tier paper, paper 1, June 2022. This is the part 2 of the question paper solving video where we're going to be solving from question number 6 to question number 9. Question number 6. Molten sodium chloride is electrolyzed in an industrial process to produce sodium. Figure 8 shows a simplified version of the electrolysis cell that is used. We can see the diagram where we can see molten sodium chloride is the electrolyte. And in one side, we're collecting the chlorine gas, and in the other side, we're collecting the molten sodium. Since the molten sodium is lighter than the molten sodium chloride, it's floating at the top, which is the correct half equation for the production of sodium. So for the production of sodium in this case, in sodium chloride is a sodium ion. It will be accepting an electron, and that will cause it to become sodium metal. So sodium ion accepting an electron turning into sodium metal. This one will be the correct answer. A mesh is used to keep the products of the electrolysis apart. Suggest one reason why the product of the electrolysis must be kept apart. So you see, chlorine and sodium under normal atmospheric, room temperature and pressure will react with each other to produce sodium chloride salt. So it's very important because we have molten sodium chloride. It's a very high temperature electrolysis process. So for that reason, we'll have to keep them separate so they do not react. Which type of particle passes through the mesh in the electrolysis of molten sodium chloride? In the molten sodium chloride, we can see the mesh only allows the molten sodium chloride to pass through it. And molten sodium chloride contains ions of sodium and chloride. So the answer will be ions. Aqueous sodium chloride solution is electrolyzed in a different industrial process. Two gases and an alkaline solution are produced. Which two ions are present in aqueous sodium chloride solution in addition to the sodium ions and chloride ions? We have to understand when we say aqueous, that means that we have water present. That means water will split into H plus ion and OH minus ion. Name the alkaline solution produced. So the alkaline solution produced will be, because we are going to be producing our two gases, and one of the gas in this process will be hydrogen, the other gas will be chlorine. So the remainder of the solution, the ions that are remaining in the solution is Na plus and OH minus, which will produce sodium hydroxide. Explain how the alkaline solution is produced. You should refer to the processes at the electrodes. Because they have asked us to mention the processes at the electrodes, alright, we will talk about what ions are left in the solution. So guys, sodium ions and hydroxide ions are left in solution. Because hydrogen ions are discharged as hydrogen gas at the cathode, and at the anode, the chloride ions are discharged as chlorine gas. Basically what happens is the hydrogen ions, they get reduced. They gain electron and then they become hydrogen gas. And for the chloride loses electron, so they get oxidized, and then they turn into Cl2 gas. Both of these gases are diatomic, by the way. This question is about silicon and compounds of silicon. The reactivity series sometimes includes nonmetals such as carbon, hydrogen, and silicon. Silicon can be extracted by reducing silicon dioxide with different substances. And the equation, 2 carbon reacting with silicon dioxide, silicon is produced and carbon monoxide is produced. Explain what this reaction shows about the position of silicon in the reactivity series. Since we can see that carbon can take away the oxygen from silicon, so definitely silicon is lower in the reactivity series below carbon. Aluminium also reduces silicon dioxide. Carbon is used rather than aluminium to reduce silicon dioxide because carbon is cheaper than aluminium. Carbon can be obtained by heating coal. Aluminium is obtained from aluminium oxide. Explain why aluminium is more expensive than carbon. The production of aluminium requires the process of electrolysis already. So, it requires a lot more energy, compared to that of carbon. Whereas, if we burn coal, we can just get carbon. And coal is pretty much very cheap. So, compared to coal, aluminium will be very, very expensive. Magnesium also reduces silicon dioxide. Magnesium reacting with silicon dioxide produces silicon and magnesium oxide. Give one reason why the products are difficult to separate if magnesium is used to reduce silicon dioxide. The main reason here is simple, because magnesium oxide is also a solid and silicon is also a solid. What happens is that they can, mix together and we won't be able to separate it out, or by normal means. Probably a chemical process can then be used to separate it out. However, it can prove to be very difficult. Calculate the minimum mass in grams of magnesium needed to completely reduce 1.2 kilogram of silicon dioxide. So guys, in a question like this, in the first step we should do is we should find out the amount of SiO2. Once we find out the amount of SiO2, then we need to convert the 1.2 kilogram into grams, which will be 1200 grams. Then we're going to find out the number of moles of silicon dioxide by dividing the 1200 with 60, which gives us 20 moles. So now we need to calculate out how many moles of magnesium we're going to need. Since we need twice the quantity of magnesium, all right, compared to that of the silicon dioxide, according to the equation. So we're going to need 40 moles of magnesium. Then what we need to do is to find out the mass of magnesium, we need to multiply the number of moles of magnesium with its relative atomic mass, which is 24. And that will give us the mass of magnesium that is needed. Now, if they were to ask us to find out the mass of magnesium here they asked us to find the mass of magnesium in grams. But if they would ask to find us the mass of magnesium in kilogram, we would then just divide it by 1000. Si2H6 is equivalent compound of silicon and hydrogen. Complete the figure 9 to show the outer shell electron in a molecule of Si2H6. So here the silicon can be represented as dot and the hydrogen can be represented as cross. So we can represent all the crosses from the hydrogen. Then we can mention the silicon's dot. Si2H6 reacts with oxygen. The equation for the reaction is 2 Si2H6 plus 7O2, 4 SiO2 plus 6H2O. 30 cm3 of Si2H6 is reacted with 150 cm3 of an excess of oxygen. Calculate the total volume of gases present after the reaction. All volumes of gases are measured at the same temperature and pressure. To answer this particular question, we need volume of oxygen. All right. Now, we are already given that we are using 30 cm3 of Si2H6. Since we are using 30 cm3 of Si2H6, so we will find out the proportional ratio of the volume of oxygen needed. All right, which will be 7 divided by 2 multiplied by 30. And once we find out the volume of oxygen, then we can find out the volume of excess oxygen, which is 150 minus the answer from the previous calculation. And once we do that, we can also calculate the volume of water vapor. Once we calculate the volume of water vapor, we can then add the volume of excess oxygen plus the water vapor, and then we will get the volume of gases at the end of the reaction. Explain why the pH of an acid depends on the strength of the acid and the concentration of the acid. In a question like this, guys, we have to think of what does pH means. pH means power of hydrogen. That means what is the concentration of H plus ion that we have within that particular acid. If the concentration of H plus ion is higher, then lower the pH. So the strength, why do we need the strength of the acid? All right, because a stronger acid has higher ionization or higher dissociation, meaning it is more likely to break down in water and form H plus ion. So it will generally give a lower pH. All right. And we need a higher concentration because the higher the concentration of an acid means that the more H plus ion it can produce in a small volume of solution. All right. So higher the concentration of H plus ion means lower the pH. So both strength and concentration of acid is important when we want to have a lower pH. A student titrated 25 cm3 of hydrochloric acid with 0.1 mole per dm³ barium hydroxide solution. Able to show the result. We can see there are a total of 5 titrations that are done and they have close results. However, we need to find out the concordant result. Remember, a concordant result occurs when the titration volume is within 0.1 cm3. The student calculated the volume of barium hydroxide solution to be used in the titration calculation 23.50. Explain why the student used a volume of 23.50 barium hydroxide in the titration calculation. So the student actually, here we can see that has averaged. All right, the student has averaged. Since the student got the same result repeated twice, so the student can choose one of those results. And the closest result to that particular result within 0.1 cm is 23.55 and 23.45. So the student did average of those. The student did not use 23.90 because it is anomalous. It is not within the 0.1 cm cube range. "25 cm cube of hydrochloric acid reacted with 23.50 cm cube of 0.1 mole per dm cube barium hydroxide solution. Calculate the concentration of hydrochloric acid in mole per dm cube." Guys, in the equation, we can see 2 hydrochloric acid reacts with 1 barium hydroxide. So we can write down the reaction stoichiometry as 2:1, producing 1 ratio of salt to 2 ratio of water. So in the first step, what we need to do is we need to find out the moles for barium hydroxide. And we can do that because it contains the volume and also contains the concentration. We will use the formula number of moles is equals to volume into concentration. And since we have 23.50 in cm cube, so we're going to divide the 23.50 by 1000 so that we can get the volume in dm cube, and then multiply with the concentration, which is already mentioned in mole per dm cube. Once we do that, then we will find out the number of moles of barium hydroxide. Once the barium hydroxide moles is found, we will double that number to find out the number of moles of hydrochloric acid. Once we get the number of moles of hydrochloric acid, we know the volume. All right, so then we will be able to use the same formula. Number of moles is equals to volume into concentration, but this time we're going to find out the concentration. And then we will be able to find out the concentration by using that particular formula. Again, we need to remember, because the volume of hydrochloric acid is given in cm cube, so we need to divide it by 1000. Now the student titrated sulfuric acid with barium hydroxide. Sulfuric acid plus barium hydroxide produces barium sulfate and water. The student measured the electrical conductivity of the mixture during the titration. The better a conductor, the higher the electrical conductivity value. So we can see volume of barium hydroxide solution added in cm cube, and electrical conductivity in arbitrary units. So as we increase the volume of barium hydroxide, the electrical conductivity is decreasing. The reason can be that we are removing the H plus ion by the addition of the hydroxide ion, and that is producing water, and water is less of a conductor. Now explain why the electrical conductivity of the mixture was 0 when the sulfuric acid has just been neutralized. So there are no ions that are free to move. That is one of the reasons. And actually, we are producing barium sulfate when we are adding barium hydroxide to sulfuric acid. And barium sulfate is a solid, so it doesn't contain any free ions. And hydrogen ions, which reacted with the hydroxide ion to produce water, water is a poor conductor of electricity. So thereby the conductivity goes to 0. The student then added a further 10 cm cube of barium hydroxide solution. The electrical conductivity of the mixture increased. Explain one reason why. So when the student added a little bit more, like 10 cm cube of barium hydroxide, the mixture now contains barium ions and hydroxide ions which are free to move, and those ions can conduct electricity. Guys, thank you for watching the video. If you like the video, guys, give a thumbs up. All right, and write in the comments if you want me to solve any of the question papers of your choice, and see you in the next video.